affiliated with integrating wind onto diesel power plants. So often we look at the wind side of the equation, and so we're taking this morning to focus on the diesel side of the equation to make sure that we're balancing and viewing our design and looking at our options from a system-wide perspective, not just wind or not just diesel. And so to do this, Per Lindsager is going to moderate this session. And to formally introduce Per, although lots of us know him, I'd like to highlight that he is a PhD in structural mechanics from the Technical University of Denmark, and he started working full-time with wind energy in 1975, including work on energy systems and concepts for wind energy and other renewables. Between 84 and 93, he was head of the wind diesel development program at Risø National Lab, and as senior consultant, he's been advisor to the National Wind Energy Centers in the USA, Canada, Finland, Denmark, Russia, Estonia, Poland, Brazil, India, and Egypt regarding projects, programs, and strategies. He's also been manager in projects and studies in the USA, Canada, and Europe, including Greenland, Eastern Europe, Africa, and Asia. He's now retired from Risø, but he's still active as a consultant with Darup Associates, his business, in the application of wind energy, including isolated systems with wind power. His clients include the World Bank and WIDAC. And so Per does work with the University of Alaska Fairbanks as an advisor mentor faculty for the WIDAC program. So we're really thankful to have Per's expertise, helping to direct our research agenda at WIDAC. So thank you, Per.
Thank you, Kat, and thanks for all of you coming to watch this session instead of staying at the coffee shop. Yes, I will start by giving a few views of mine, personal views, on the diesel issues. And what is my wind diesel background? Basically, Kat said it. I was head of the Risø wind diesel program. But what I'll focus on there is that what we did in this program was to base our research on an experimental system we developed that we called the simple, robust, and reliable system, based on the fact that a lot of the systems had failed because they were too complicated too soon in the development. Later on, I consulted on several systems, but we were through that. And what is the simple, robust and reliable system? In our system, it was we connected a standard 55 kilowatt wind turbine with induction generator to a 34 kilowatt diesel genset modified with an electromagnetic clutch. And this high rating of the wind turbine was in order to stop any discussions that you could not put a lot of wind into a diesel system. We did that. And by having a clutch between the diesel and the synchronous generator, we could allow the synchronous generator to act as a synchronous condenser when the diesel was stopped. And we had absolutely no supervisory control to begin with. The system balanced itself by the component controllers. We had a flywheel fixed to the synchronous generator so that in cases where we suddenly lost power from the wind, we could bang the clutch and then start the diesel as an emergency UPS system. We had no battery storage. And I have to say that even if we abused the diesel violently, the system was actually alive in a regular research and development operation until it was replaced in 2004. Not because the system failed at that time, but the installation went to different objectives. And we used the diesel genset in regular low load down to 0% load regularly during its entire life. And we even, together with Bob Sherwin, which some of you may remember from Atlantic Orient, we made some backdrive tests where we saw how much could the system absorb of wind energy, the diesel generator, before it stopped to regulate the system. And we operated down to minus 25% negative load without any kind of stability problems. But of course, when the diesel regulator hit bottom, then it stopped regulating frequency and then the system got unstable. And again with that, it worked until 2004. And at that time, the experimental setup was replaced by an installation called SysLab, which is aimed at wind integration on large grids. because that's what we have in Denmark. That one, yes. And to put it squarely, I'm not a diesel guy, but I'm son of a diesel guy, so I kind of grew up with diesel engines. He was a deputy director on a diesel locomotive factory, and to brag a little on his behalf, the company in 1932 delivered a 16 horsepower diesel electric locomotive to the Siamese Railways. And I know that at the same year, General Electric was very impressed by having a Drasin with 32 horsepower in diesel electric. Later on, one could say that General Motors steamrolled everybody. Anyway, generally, wind guys do not understand the diesels very well. There are these two disciplines that need to work together. And the wind guys do not understand diesel very well. They tend to have strange ideas about what can be done and what cannot be done. So in the wind diesel setup, wind guys should always try to stay close to a diesel guy. And that should go the other way also. The diesel people should listen, of course, carefully to what are the needs and behaviors of a wind system. The basic thing in a wind diesel system, or all of you know that of course, but now I say it again, whether it's a wind turbine retrofit or an entire system, is that all the equipment that is in addition to a box standard diesel genset, and that includes of course the wind turbines themselves, have to be paid for primarily by the fuel savings. There may be other benefits also, but as it was said yesterday, the operators are not willing to pay for that. That money that the system saves for say, an environment that these whatever it is, comes from a different money box. So basically, all that we do with wind diesel systems has to be paid for by fuel savings. And therefore it's very important that the wind into a diesel power plant replaces as much diesel as possible. And that's not a diesel person's primary goal, because they take pride in their systems being able to deliver full power at any time using diesel. We have a different objective, that's why we often discuss these matters. So because of that, the low load operation of diesel is possibly one of the hottest diesel issues right now. And as you'll find out, I have my opinions, but you are of course free to have yours, and I hope later in this session to have the floor free to discuss these different opinions. Everybody knows this, but I'll repeat it again. If you look at the basic function of a wind diesel, take a system which has a 100 kilowatt constant load, and you put in a wind turbine, and then you watch as wind speed increases. Then what you see then is that wind power increases, and the diesel controller registers that, and therefore it reduces load on the diesel. Then comes a point where the manufacturers say you are not allowed to load the diesel lower than so and so many kilowatts, and that's embedded in the control. So therefore, even if the wind increases and the power from the wind increases, the diesel generator keeps its rated power and put it in, and that appears as either waste or you have to use it for something else useful. You don't use it in the primary load. That's the fact. And if you take a system like that and put into a simple model, you'll see that if you run the diesel at 50% minimum load, you will have a relative fuel saving of 52% compared to what you could have if you were allowed to go down to 0%. So that means that by allowing it to go down to 0%, you can double the fuel saving, and then they're all right in between. And that's really the basic thing in that. That's why we need to discuss low load operation of diesels, whether the diesel manufacturers like this or not. And to put it, we had a funny incident many years ago, early before we had this Alaskan wind diesel conferences. We had a long time where we had an alternative wind diesel conference, 1 year in Canada, another year in Vermont. And in one of these wind diesel conferences, we had actually diesel manufacturers, Caterpillar, Detroit Diesel, and another one which I forgot was. And we had the diesel manufacturers, technical people sitting there. And there we had this discussion again, and the usual religious war about what's possible came up. And then to stop that, I stood up and asked the diesel manufacturers, suppose I come with my pocket full of money and I want to buy a diesel set with you, and I want to put it in a system where I'll operate it at zero load. Are you willing to sell? And to everybody's surprise, the guy said, yes, of course, that's what we are here for. Okay. But they also said that when doing that, we need to have you fulfill certain conditions. And that, in my mind, is the situation. You can discuss with the manufacturers to go down to 0%, and then discuss with them what limitations and what things do we need to take into account when doing that. And as I say, therefore, it's my opinion that you need to maintain proper communication with the diesel manufacturers. And you need to listen carefully to what are their demands. One of the things I know all diesel manufacturers have in their drawer without showing the customers is a curve saying if you have the diesel working so and so long time at too low load, then you need afterwards to blast it through for so and so long time to clean it for all this stuff. That's one of it. I also have a method that includes mineral water, but there are many ways to deal with that. But I'm really convinced that it's possible to do that, and I'm also convinced that we need to be able to do that in order to have the fuel savings we need to pay for the systems. And then we have a lot of other issues also that I don't deal a lot with here. But for instance, just one thing here in Alaska, operation, maintenance and repair in cold climate and remote situations. That's certainly an issue. Scheduling a dispatch of multiple diesel units is another issue, how to deal with that. And start and stop strategies, how do you design your control system so that the diesel doesn't go on and off a lot of times. And I hope we'll get a chance to hear about that later. Okay, that's my, you don't have to listen to all that, but that's my long life. So, then the situation is that one of my friends, Søren Vestersen, is head of a company producing wind diesel systems. And I persuaded him to give a presentation here. And he said yes, and he has given this presentation. But he's not able to come because he's at a meeting in Lisbon right now in connection with this project I talked about yesterday in Cape Verde, where Vestas is going to install 28 big wind turbines in the Cape Verdean diesel grid. And Vestas uses Søren Vestersen as their diesel department, so to say. So whenever they promise to make wind diesel systems, they call on him, so that's why he cannot come. So I'll give his presentation on behalf of him. And to put it in place, Søren Vestersen is a founder and CEO of Danvest Energy, and that company is now a wholly owned subsidiary of Australian Wintershall Limited, a company that markets desalination system based on wind energy. Søren is a real diesel guy. He has worked all his life in diesel engine development, manufacture and sales. So he knows diesel people, he can talk to diesel people in the language they accept. The system he has developed, am I talking too much?
I was just going to pull up his PowerPoint.
Can't say.
I was just going to pull up his PowerPoint for you.
Okay, thank you. Thanks. Yeah.
No, keep talking.
Okay, yeah. Anyway, but he started making a simple wind diesel system where he included a desalination component to take care of excess power. And in that process, he developed a technique for operating the diesels at low load, which he has taken a patent on, worldwide patent. And to make a thing very clear, now Søren talks a mile a minute, and he's a great salesman. So what you see now is a sales pitch, and it's important for me to say that I'm not part of his company, so it's not my sales pitch, and I'll skip a lot of that and try to stick to the things that I think are essential here. But you will of course get the whole stuff on the screen, but keep me out of the sales. I'm not an agent for him. The presentation, as you can see, introduction and wind diesel with high penetration, working principle, and so on and so forth. That's what in this presentation. And Søren started his work in 1993, and as I said, the low load operation is covered by a worldwide patent, and that's the patent he has. And they have always had a close relationship with Vestas Wind Systems, who actually took over the intellectual property rights in a period where Danvest was at a very low economic level. That doesn't mean that he couldn't supply systems with any wind turbine manufacturer. He's not bound to deliver. His company was bought by an Australian company, this Wintershall Limited. And that's a way to get the money, who cares? But they're busy implementing plans, but that's plans, not contracts, for developing up to 16 wind diesel desalination plants in South Australia. And what Danvest works at, intends to do, is the wind diesel for power supply for off-grid, regional and remote areas. It doesn't mean that he's not focusing only on small systems. One of the proposals I've seen from him deals with a 100 megawatt system. And as he said rightly, when there's no wind, there must be a diesel engine. I know there was suggestions yesterday on how to do it without a diesel, but in his view, when there's no wind, there must be a diesel engine to secure the power supply. And there he says that Danvest has made a standard diesel engine able to back up with wind turbines between 0 and 100%. And everybody can take a diesel like I did at Risø and connect it and do whatever I want with it. The main thing here is that in Danvest's system he has obtained the manufacturer's acceptance of providing the normal warranties. And that's what you want when you want to sell a system to a community. You want to be able to provide the full component warranties. And in the systems he has developed or proposed, 50 to 85% annual wind penetration. And as you say, based on the prefabricated containerized concept. The last line is important. They have a worldwide service via internet with link to local service organizations, meaning that everybody providing a component, and that goes for diesel manufacturers also, get an access to the control system of the system they have, so that, for instance, diesel manufacturer can go in and check exactly what is Søren doing to his system, and do they need to react or do anything. Say a low-load unit, that's the one that is patented, and he has a way, since he has a clutch in the system, he can disconnect and stop the diesel engine, and then he has, say, a very good control, and I'm sure that's right. And yeah, that's true. And concept based on standard diesel generators and standard wind turbines. The standard wind turbine part is right. The diesel generator is not exactly standard, as he has this clutch put in between the diesel engine and the synchronous generator. And he keeps the diesel happy by preheating and pre-pressure. And I got a long story from him about what is pre-pressure. It has to do with the fact that at low load you don't want the diesel to have suction in the combustion chamber, because then it pulls oil up along the pistons, and that gives unwanted consequences for that. So he has a system diagram no different from anybody else, except that here you have the clutch that allows him to use the synchronous generator as a condenser. This is the sales pitch, which you can read in the proceedings when you see it. And he, of course, also in his systems, when we have wind penetration below 100%, it's the diesel engine governor who controls the frequency. Then he has a dynamic dump load to take care of situation where wind occasionally goes over 100%. When the wind turbine is producing more than the primary load, then he has the diesel control thing, which he calls a dump load, but it will normally be used for what we call optional load, heating or freezing or whatever it could be. It's not wasted. And when the diesel engine is stopped, then the synchronous generator keeps rotating, take care of the voltage control. And that's what the next one says, and the last one, yes. Here we have the thing about the optimal diesel operation low load unit, pre-pressuring to secure positive charge air pressure. That's what I talked about. The thing that avoids the diesel, prevents the diesel from pulling up lubrication oil. And also preheating the cylinder head for optimal combustion. It's a way of keeping the diesel happy when the diesel is at low load. And of course it's based on the fact that when the diesel is at low load, then you have a lot of wind energy. So you have some heat to do good with, to keep the diesel happy. This one I don't understand. Then I'll talk a little bit about these curves. They are not self-evident, so I talked to him and took some notes. He had another test facility with a 1 megawatt wind turbine on a 625 kilowatt diesel set. And these are curves from that. And here you simply see an operation with the consumer load more than what the wind can do, and there you have the interchange between the wind turbine and the diesel engine. And then we have a situation where the wind speed is making so that the diesel in average produces average load, but sometimes it produces more than you need and sometimes less. And that reflects in the output from the diesel engine. You'll see sometimes the diesel engine goes in load and even in negative load here. And here then is what he calls the dump load, the optional loads. And here we have the wind significantly higher than the load, and therefore you have long periods where the diesel is stopped. Once in a while the diesel gets started, but mostly the diesel is stopped. And this is more or less the same as the first view graph, where you can see that once in a while the dump load tricks in. here we have a situation where you start with high wind and the engine is stopped. And then the wind disappears and you have to start the diesel, and well, that's what he shows here. And somewhere in here, it's not very clear on the screen, is a curve, a white curve that you cannot see, but that's the frequency. And it's expired and saying the frequency is rock solid. The frequency doesn't feel all these operations of the systems. And here we have a situation where, let's see what it says. You have the load, the blue load, and you have a diesel stop for whatever reason it is. But then you start the diesel. I'm not sure that's right, this. So let's go to the next one. That one I understand. You have a stall-regulated wind turbine working at high wind, and therefore the diesel engine is stopped here. And then what happens if you have either a failure on the turbine or it for some other reason is stopped? That's what he does here. He stops the wind turbine. And you see the diesel engine coming in and taking the load without any problems. If you could see the white curve, you would see there's a small cusp in the frequency. The frequency reacts a little bit, but it's very little. So these are actual measurements, not modeling things. It's actually measurements on the system he has. In the
Is the yellow the dump load?
Yeah.
So when the diesel starts up, the dump takes some of the energy to moderate it? Is that what's happening there?
It looks like that. That was a sharp look here. I cannot explain that, but you're right. It seems to do that, and it shouldn't. You told me about this. I cannot explain that, sorry. But you're right, it shouldn't. It should stay down because there's no need for it. But it comes up suddenly and then it goes down to zero. And I can't explain that.
What's the time scale?
Pardon me?
What's the time scale?
What is the...
Time scale. How long is that?
Okay, yeah. I need some light to see.
Looks like
No, but what's the time scale of this?
7:34 to 7:30. The whole thing represents about 2 minutes.
Thanks.
Yeah.
Yeah.
Mhm.
And then a little pep talk, what is necessary. This one, surplus energy should be absorbed for utilization. I call it dump load all the time. Of course, it should not be a dump load with waste. It should be used in various things, and he can use it for desalination if it's connected to a desalination system. And then, again, the most important thing here, again, is that also the diesel manufacturer, the way that Danvest used the system for low load, the diesel generators always come with the manufacturer's full warranty, which I think is quite an achievement. Why doesn't it?
Okay, now try.
No, it's not the end of it. Yeah. What did you do? You took that one. Yeah, okay. That's a curve all of us have seen a ton of times. And that is sales pitch, again sales pitch. And here it's a little bit about the sizes he supplies systems in. This one I simply don't understand. This is systems that he has actually installed. Estonia, he has provided a wind diesel power station on a small isolated island. In Ireland, he has put in a wind desalination station, and in Malaysia, he refurbished a malfunctioning wind diesel station in 1995. And then he has had a test station in Denmark. He has actually had 2 test stations in Denmark where he has developed a system in this period of time.
Eric,
Yeah,
do you know if any of those are still operating?
as far as I know, all of these are working still, also the one in Malaysia. Yeah. And then, excuse me, he's a very active guy, and you need to be that in order to get contracts. So he has a very long backlog of proposals, which for one reason or the other didn't become projects. And I'm not sure if that is a contract he has or another proposal. I believe this is a system he is building now, because he has then a long list of proposed situations which has not been to anything. All this is systems where he has worked out proposals, and all the proposals he has made has been checked with a diesel manufacturer so that he could provide the proper warranty. So he has been very busy with that, and once in a while he sells a system. And now he has this contract I talked about, that he, together with Vestas, he is installing systems on the Cape Verde diesel grid to the extent of 28 big wind turbines put into their network, which will push the wind penetration on the national network in Cape Verde to 25%. So even if I'm not his agent, I have to say I'm pretty impressed of the way he deals with the diesel manufacturers. In my mind, that's the way to go. More project proposals. And this is a model how they now, in the wind desal company, could see a wind designation plan work. And questions, they are not here to be put. You put questions to me, I'll do what I can to answer. That's it. This one. Thank you for your patience in a rather confused presentation, I know that, but since the guy itself could not be here, that's what you got. Time for a few questions if there are any, but then again, after this session, we'll have a local workshop where I think we could take whatever discussion you need. So in a way, I'm prepared to go to the next presentation now, and then we take the real discussion at the end of the session, if that's okay with you. It seems to be the case, so let's have the next one.